Hello, ladies and gentlemen. Today, in this video, we're going to take a little bit of a look at solving by square roots and dealing with square roots in general. So how do we work with things that have radicals? How do we simplify them? How do we isolate x using a square root? Okay, so first thing we need to be able to understand is how to simplify a square root, because using this method to solve, you're going to get square roots in your answer. So we need to remember how to simplify something like this. So if I take a look at this fraction right here, I have a 14 over a square root of 12. Now notice the only thing that's in a square root is the 12. So I'm just going to leave that 14 alone for right now and worry about this square root of 12. How can I break apart that square root of 12 using a perfect square? Well, our perfect square numbers are numbers like 1, 4, 9, 16, 25, 36, numbers that we know the square root of. I know these numbers because I know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So this list of perfect squares needs to be something that we're familiar with, because then I can ask myself which of these numbers divides out of the number 12 evenly. So 12, does it divide by 9? No. Does it divide by 16? No. But it is 4 times 3. 4 divides out of the number 12 evenly. So the square root of 12 is split apart into a square root of 4 times the square root of 3. But the square root of 4 is something we know. We know that this part becomes the number 2. And we know that the square root of 3 is something that isn't a perfect square, right? It's that decimal value. So we're going to leave that part alone. It can't be broken apart any further. So far I have 14 over 2 square roots of 3. Now, what's nice about this answer is that we've broken apart that 12. What's not so nice about this answer is that we still have a square root of 3 right down here in the bottom of this fraction. Now, we can't leave a radical in the denominator, so we need to multiply the bottom of the fraction, the denominator, and the numerator by that square root of 3. This is called rationalizing the denominator, okay? And if I look at what I've created now on the top, I've created 14 square roots of 3 over, on the bottom, I still have that 2 that's just hanging out, right? But now I've created this. Square root of 3 times square root of 3 makes square root of 9, which means I have 14 square roots of 3 over 2 times, what's the square root of 9? Well, that's just 3. So I have 14 square roots of 3 over 6. This is great. This is pretty good. But one more thing can be done. What is 14 over 6 simplify to make? Well, that is 7 over 3. If I divide both the 14 and 6 by the number 2, I get 7/3. And I'm just going to leave that square root of 3 alone on the top. So this is my final simplified answer. So we're going to need to be able to deal with some square roots because we're going to solve using square roots. Remember, we need to isolate the squared term, square root both sides, simplify, and solve. So let's take a look at this one example here. In order to solve for x, I would first add the 3 over. So I'd have x plus 1, all being squared, equals 8. And now I need to get in and isolate that x, but I have to get rid of that squared. I have to do the opposite, which is square root. So on the left-hand side, I now would just have x plus 1. On the right-hand side, I need to go ahead and simplify this square root of 8. The square root of 8 is the same thing as square root of 4 times 2, square root of 2, okay? So 2 square roots of 2 is what that beautiful square root becomes. He's broken apart now, and now we have a plus or minus in front, and at last but not least, I would go ahead and subtract the 1 away from the x, so I'd have x equals -1 plus or minus 2 square roots of 2. And I would leave my answer just like this, okay? There's my single answer. That's what x equals without having to find any decimal approximations, okay? So that's how we would solve by simplifying a square root. Thank you again. I'll see you later, Sabers. Kincaid out.